Right, today in geometry, we're going to review the apothem, how to find the apothem, and then review some volume of prisms. So first, let's talk about the apothem again. The diagram shows a regular polygon inscribed in a circle. The center of the polygon and the radius of the polygon are the center and radius of its circumscribed circle. The distance from the center to any, we're going to add in here midpoint, to any midpoint of a side of the polygon is called the apothem of the polygon. The apothem is the height of an isosceles triangle that has two radii as legs. Therefore, we can say that our apothem is perpendicular to the side, since it's the height of an isosceles triangle. So here we have this picture. We have our center, our radius. This is the apothem down, so AC. A central angle, again, all of this is going to be review for us. So remember, a central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of the polygon. To find the measure of each central angle, recall that we just divide 360 by the number of sides. So we're going to go back up here to this picture. We're going to identify everything we know. So our center, a circle, right, is A. So our radius, we have AB as well as AD. We have our apothem, which is AC. We have the isosceles triangle, BAD, where AC is the height of that. We have our central angle, which is, again, angle BAD. I want the measure of angle BAD. It's 360 divided by, here we have 1, 2, 3, 4, 5, 6. We have a hexagon divided by 6 gets us 60 degrees. So now it tells us ABCD is a regular pentagon inscribed in circle F. Find each angle measure. So we're just going to practice this. So let's just label A, B, C, D, and E. We want to go ahead and draw our isosceles triangle. So draw our radius, AF and AB, or sorry, AF and BF. That gets us isosceles triangle. So then draw our apothem, and we'll label that G. Okay. So the measure of angle AFB, this is our central angle. Remember, this is always 360 divided by how many sides our polygon has. This is a pentagon, so we have 5 sides. 360 divided by 5 gets us 72 degrees. So now we want the measure of angle AFG, so this little angle in here. Remember that AFB, okay, that is our isosceles triangle. When we drop that height, FG, our apothem is the height, we cut this side in half, and we also cut that central angle in half. So 72 cut in half gets us 36 degrees. So now we want the measure of angle GAF, this angle down here. Well, those two are complementary, so we just found that this one was 36, so 90 minus 36 gets us our other one at 54 degrees. So then we have the theorem for the area of a regular polygon. So we have seen this formula before when we were doing our surface area and volume. The area of a regular pentagon with a side length S is 1/2 the product of the apothem A and the perimeter P. So the area is equal to 1/2 apothem times the perimeter. We've been using this. So we'll look at an example. You're decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides. So that means all of these are 15. A radius of about 19.6. So if I look at my center, my radius, so these are each 19.6. So what we've done here, now we have this isosceles triangle. I know that this is 15, this is 19.6, and this is 19.6. What is the area you are covering? So we want to find the area of that. Okay? So again, our formula, area equals 1/2 the apothem times the perimeter. We can easily find our perimeter since we know all sides are 15 and we have 8 sides. So 8 times 15 gets us 120 inches for our perimeter. So really we need our apothem, which is this. Right? This is our apothem. So first let's find that central angle up there. So our simple angle is always 360 divided by the number of sides. We have 8 sides, so that's 45 degrees. So now when we look at this side, this is 19.6. We drop that height, so that cut this in half. So this is 15 halves. It cut 45 in half. So 45 cut in half is 22.5 degrees. So this angle now is 22.5 degrees. We're looking for our apothem. Remember that we've got SOHCAHTOA here, or we could do Pythagorean theorem. Okay, so either Pythagorean theorem, since I know both of these two, or SOHCAHTOA. I'm just going to do SOHCAHTOA to practice that. So I am looking for A, so that's adjacent, and then I'm going to use the 19.6, my opposite. So that's cosine. So it's the cosine of 22.5 equals A over 19.6. I'm going to cross multiply. So 19.6 times the cosine of 22.5 equals my apothem. So my apothem is equal to 18.1080. So now the area is equal to 1/2 my apothem, 18.1080 times my perimeter, which was 120. Multiply all of that together, and we end up with the area that we are covering as 1,086.5 square inches. Okay, so now the next thing we're going to look at, this is going to be your homework. We're going to review some of these together. So we're going to do some of your homework together today in class to review this. So volume of prisms. Remember that the formula for the volume of a prism is capital B times H, where capital B is the base of the prism and H is the height of the prism. So 1 through 3, find the volume of the solid by determining how many cubes, how many unit cubes are contained in the solid. So we're going to do number 3 together. If I want the volume, what they give to me, first, let's just pretend that this was an entire prism. And we're going to find the volume of that entire prism. So since it's a prism, okay, remember these are the easy ones, length times width times height, since it's rectangular prism. So the entire length, let's see, from here to here is 10, but this part is 3. So this entire top is 13. So we've got 13. This is 5, this is 2, so the entire side over here is 7. And then let's see, our width, we see we are 2 inches deep. So 13 times 7 times 2 gets us the entire volume, which is 182. Now we need to take this section out of that. So we're going to have 182 minus, let's find the volume of this little area up here. Okay? So the volume of that, again, length times width times height. So it is 3 times 3 times 2 minus, now we want this one, it's 7, 2 high and 2 deep, so 7 times 2 times 2. So we end up with 182 minus 3 times 3 is 9 times 2 minus 18. 7 times 2 is 14 times minus 28. So when we subtract all of that, we get 136 cubic units. So to find the volume of these, find the volume of the entire rectangular prism, and then find the volume of what was missing and just subtract them out. Okay. All right, so now we're just going to scroll down and we'll look at number 7 together. So this is a triangular prism. So our volume, okay, the area of the base, my base is this triangle. All right. So the area of a triangle is 1/2. The base of the triangle we see is 2. Since it's a right triangle, remember it's your 2 legs. The height of the triangle is 5. So that's our capital B. Now times the height of the entire prism, 8. So 5 times 2 is 10. Half of 10 is 5. 5 times 8, 40 cubic inches. Okay, so now we're going to go to the next page. We're going to look at number 10 together. So here they give me the volume and we have to find the missing length. Okay? So number 10, again, it's a triangular prism. They tell me that the volume is 600. We want to find the height of the prism. Okay? Again, I know that my volume is going to equal 1/2 base times height of the triangle times the height of the whole prism. They told me the volume was 600, so 600 equals 1/2 this side and this side of my triangle. So 7 times the entire height, that's x. That's what we're looking for. So I have 600. So 7 times 7 is 49. Half of 49 is 24.5x. I'm trying to get x by itself, so I'm just going to divide both sides by 24.5. And I find that x is equal to 24.5 centimeters. So our height was 24.5 centimeters. All right, so the last page, we're going to come over here and find number 14. Find the volume. Again, notice that we have two different rectangular prisms. We have the great big one, then we have the one on the inside. We want the volume, so we need to find the volume of each of them, and then subtract the one on the inside from the one on the outside, because we're taking all out. So the volume of the one on the outside. So the great big one. So 4 times 5 times 6. So that's 120 cubic millimeters. Now we want the volume of the one on the inside. So the one in the dotted. So let's see, this one, they tell me, is 3 times 4. My height is still, so 3 times 4 times 6. So 3 times 4 is 12. 12 times 6 is 72 cubic meters. So now I want the total volume. So it's the outside, 120, minus, we're taking away that on the inside, 72. And that's going to get us the total volume of 48 cubic millimeters. Okay? All right, so your homework is going to be finish this worksheet, the ones that we did not do together. There will be some of them on here where you have to find the apothem. Okay, so that's why we went over remembering how to find the apothem and find the area of a polygon, because on this homework assignment, number 6 and number 9 and then like number 16, you're going to have to do that. So this is a nice practice finding the apothem. Tomorrow we will look at a volume of applications, so our word problems.